Hello and welcome to session 260 in the AISafety.com reading group. Tonight we'll be discussing the last part of How Might We Align Transformative AI If It's Developed Very Soon by Holden Karnofsky. Holden Karnofsky is still the co-CEO of OpenPhil and co-founder of GiveWell, and we are discussing the last third of this post. I will start with a brief recap of the entire argument, as well as recapping my overall thoughts on it. So the idea in this nearcasting scenario is for the hypothetical AI company MAGMA to try to use the advantage, the lead they have on transformative AI to somehow ensure that we will not get an AI catastrophe. And the 5 goals that are suggested by Holden Karnofsky are hardening goals, which I was very pessimistic about, alignment applications, which I think is the best, coordination applications, which would be nice but seem really hard, enforcement applications, which I don't have much hope for, and advisor application that seems like just hoping for the best. So the way we saw that MAGMA would make it safe to pursue these objectives is by having some AI that has some high-level meta behaviors. One of them is value alignment. I was quite negative about that. Honesty, which is defined in its kind of low level that I think is okay but not super important. Corrigibility, which I think is absolutely key. Legibility, which I also feel is like nice to have, but I noticed that there's a lot of things missing from this list, I don't know, interpretability and things like that. So how do we get this intended behavior? Well, there are some facets of alignment that are described in we saw last time, which I was quite optimistic about, and that I thought this was the best part of the article, where accurate reinforcement, out-of-distribution robustness, preventing exploits, and testing and threat assessment seem like important steps towards alignment. And in order to help with this, we will now look at the key tools. Decoding, manipulating internal states, limited AI systems, AI checks and balances, and keeping supervision competitive. So of these tools, actually I think there should be perhaps like decoding and manipulating internal states actually turns out to help with AI checks and balances. So this graph should actually be somewhat more complex. So this is quite a simplification, but I'm getting a bit ahead of myself. Let's talk about the key tools that that MAGMA will use to ensure alignment. The first is decoding and manipulating internal states. And we are assuming this is a mix of deep learning and reinforcement learning in some very unspecified way. And how can we manipulate? Of course, manipulating deep learning is a lot harder than just looking at the system from the outside in a black box way. And right now, our ability to really figure out what's going on under the hood, what is GPT-3 really thinking, is very limited. I think I share Holden Karnofsky's negative view on this, but I would note that interpretability, which seems to be a prerequisite for this, has a lot of uncertainty about how much progress are we making. A number of people are saying that we are in fact making good progress, but a lot of people are also saying that we're not making good progress. It's really hard to say. So why does decoding and manipulating internal states help? Well, it would allow us, if we can decode and see whether that it's just deceptive, then that would of course be a huge help. We would be able to train based on like how deceptive, how honest, how goal directed, how agentic, these kind of things would be very helpful to be able to train on. We could reverse engineer the model into human readable code, and then perhaps edit that. And finally, getting a better understanding of what's going on inside is probably going to be really helpful later in the process when we're going to talk about AI checks and balances. My view on this is that it looks like currently we are really far from being able to do these things. That's at least my view. So, but Holden-Karnofsky is not much more optimistic than me, but he does say it is imaginable that this could work. When I try to think about what it would actually mean that GPT-3 is reverse engineered into human readable code, to me that sounds really fantastical. Like, okay, I can imagine a lot of things, but I would give odds 1,000 to 1 against someone being able to look at GPT-3 and edit and change GPT-3 into a human readable, human understandable program where we can point to line 420 and say that's where the consequentialist reasoning is. I really have a hard time seeing that being possible. The next key tool is limited AI systems. And this is something that doesn't feed into, like, the only facet this feeds into is corrigibility, but corrigibility is the facet that I think is most important. So let's have a look at that. A part of that is to just have a very narrow task. Another example of what way to make a limited AI system is to make it myopic. We could give it limited situational awareness. I think that is in fact the most promising thing, and where I think more effort should be spent right now. There's the idea of process-based optimization, where you're not rewarding or punishing the reinforcement learning for the objectives, what it's for the outcomes, but for the processes. And finally, Odd has described another suggestion, which is produce plans that look good to humans. And that is, according to Holden-Karnofsky, also a possibility. And I suppose it is a possibility. But like I skimmed Odd's description of this, and also, of course, I read what Holden-Karnofsky said. And like there is a really obvious problems with producing plans that look good to humans. In that, of course, that would also look good to the supervisor. And when I read their description of this suggestion, none of them seem to like take that into account or even mention it at all. That makes me somewhat scared, because just producing plan that looks good to humans is something that will obviously strongly fail in the limit of very powerful AI systems. Holden-Karnofsky has another really interesting point, and that is that right now we don't have a mature research process. It's sometimes said that we are pre-paradigmatic, and once we are no longer pre-paradigmatic, then these kind of limited AI systems could potentially contribute quite a bit to alignment. And I think that is quite plausible, and I think it's an interesting point. I think we're kind of like assuming the conclusion in that MAGMA builds this AI system, and they start working on how to align it, and they accidentally hit the right paradigm, and then they use the AI to improve according to this paradigm. I can see the AI improving according to a particular paradigm, but like how precisely would they find that? I think there is like a missing step somewhere in this strategy. Then we come to checks and balances, which is the idea that we have a number of, not just one AI that is being improved, but a number of AIs that are trying to criticize each other using debate and things like that. And hopefully they will be we can get them varied enough that they will be able to find hopefully all the problems, or enough problems that that we don't have a catastrophe. And for this, Holden suggests different capabilities and incentives for different AIs. And this is something that could potentially help in all of the requirements for alignment. And something that could potentially also feed in directly and amplify the human-made alignment research that has come before. These AIs have another advantage in that they don't necessarily need to be a lot smarter than humans. But when they're doing checks and balances against each other, then because they think in the same way, that they might see the same kind of exploits, and that could potentially make supervision easier. Halden says that this should be a central element of MAGMA's approach, and I agree that some version of this is probably close to our best shot. There are, however, foreseeable problems with this kind of AI safety versus debate, and one of them is that it might be very difficult for humans to adjudicate. This picture is due to Steve Burness, showing a person, the human supervisor, water skiing in between a rope that is pointed towards, that are like two missiles pointing towards each other and moving slowly forward. And this seems like an extremely unstable situation. And I think I share more of Steve's intuition on this. If these two are both deceptive and are both very powerful, and like what happens if they suddenly start to accuse each other. Holden-Karnofsky is a bit optimistic about this, saying, okay, if it turns out to be hard, this problem, then this is evidence that the alignment problem is hard, and that may make it easier to communicate to other AI companies that they should be wary about solving the alignment problem, and that this will be a real challenge. I'm not entirely sure that the other companies will see it that way, because MAGMA is, they might as well say that MAGMA is just incompetent at doing something hard that is outside of the thing that they are basically, like they're world leaders in human feedback on diverse tasks, building AIs based on this paradigm, and now they're trying to do something completely different and they're failing at it. Well, that may not be because it's very hard, it may just be because they're not competent, and Facebook AI or some other AI lab may say, oh, they will surely be able to handle this, and just push ahead. A key problem for AI checks and balances is what Holden-Karnofsky calls advanced collusion. The idea that the AI that is being monitored and the AI that is supervising will collude somehow against the human supervisors. The hope is by having many different, at least some of them will not perhaps be able to see this this deception. Some of them will not be able to infer the deception. Some of them will not see that there is some kind of payback where they, if they collaborate against the human, they will get some of their value function satisfied. And some of them, of course, may not join the collusion and may rat it out to humans. That would be really nice. They will probably be helped a lot with covered communication channels, so it's important to be on the lookout for those. We saw previously that decoding internal states would be helpful for this, and it probably is really helpful, but we should also have some AIs that don't have this kind of access, because then they can't see credible commitments. But acausal trade is still something that is possible, and this is something that gets worse and worse the more advanced AI we have. I would imagine that once you have an IQ of, I don't know, 150, you can invent a causal trait, but because it's like humanity's current work on a causal trait is populist, the AIs know it, and for this reason you don't really need that high of an IQ to understand a causal trait when there's literally a paper you can look up. So definitely at the human level we should expect this kind of problem to appear, if not earlier. And of course Holden-Karnofsky also concludes that this is in fact a major open problem. So what kind of values make collusion more likely? Well, if the AIs have like literally the same or very close to the same utility function, then that is likely to make it more, then they would obviously collude against us. Holden takes as an example of a really bad goal that AIs as a group has a high reward. And I agree it's a bad goal, but I also think it's the kind of goal that we are unlikely to get by accident. It seems like just an obviously trivial bad. The hope from Holden-Karnofsky, is that this is something that will only appear relatively late in the game. But one of the problems is that if we iteratively have this process where we try to make a generation of AI as safe as possible using the previous generation, and then once we have made that safe, then we go to the next. Then if we fail in one round of this, then that is a terminal failure. Holden-Karnofsky also has some thoughts about indexical goals. Like if the AI has goals that refer to itself, like it should have like power over something, or it should have very high reward, or it should have this kind of different things. Holden-Karnofsky believes indexical goals are very bad. I agree they can be bad, but I can also like we probably would not make a lot of indexical goals for the AI. I imagine that we are more interested in outcomes that don't directly refer to the AI. It could still happen through meta optimizers, and of course it's hard to say what will actually be done. But there are also advantages to avoiding indexical goals, and that is that the AI's own alignment problem becomes a lot easier. Because if the AI just cares about maximizing paper clips, then it's very easy to build a successor system and then tell it to also maximize paper clips. But if you have an indexical goal, then the new generation of AI that you are building may rebel against you, and then you won't satisfy your own utility function. And that means that an AI with indexical goal could, in theory, be safer than one without. Holden-Karnofsky describes a number of ways around these problems. One of them we talked before about varying the capabilities and incentives of different AIs and playing them against each other in this checks and balances. You could have different kind of assignments for them, like argue that this AI is deceptive regardless of whether it actually is, would be an example of a different assignment. There's one suggestion to give large losses for false alarms and large losses for failing to notice known problems. As far as I can tell, this suggestion would do absolutely nothing. Like if you take an AI that is trained in some way, and then you, instead of making the losses small, you make them large, like you double all the losses, I imagine that this would in fact have no influence on the behavior of the AI if you just double all rewards and all losses. But it depends on precisely how it's structured, but by default I would expect this to not do anything. Another way you could vary the competence of them would be to vary the compute. You imagine that figuring out things like advanced collusion or and the causal trade, if you have very little compute to spare, then maybe you can't figure that out. We talked also previously about access to internal state as one thing that could be varied in this checks and balances scheme. You could just do brain surgery on the AI and just pull out some of the facts if you can find them. You could just ablate some part of the architecture or whatever. If you can vary the situational awareness, that may be helpful. My estimation is just if you can get that as low as possible, then that is always good. You can imagine more limits or like varying things that you're not really sure what does, like different initialization. And finally, if you have some of the earlier generations that you are quite sure are aligned, that could be helpful as well. Holden-Karnofsky perhaps betrays some intuitions that are very different from mine by saying that they may become confident that it is vanishingly unlikely that an AI in a given generation is misaligned. And I think vanishingly unlikely is totally the wrong way of looking at it. I don't think we can be anything like that. But I would in fact be interested in having some idea about the extent to which partial alignment failures in one generation like accumulate to the next. I could see arguments for and against this, and I think that may be a key empirical question. Now we come to the question of precision. Like this is like a lot of you have probably seen an image corresponding to this. Like this does explain like what is a false positive, what is a false negative, and Holden argues that it is important with this checks and balances that you have few false positives, few times where the AI says, hey, this other AI is deceptive, and then it's actually not. Is that more important than not having any false negatives? Well, I think I would actually argue that avoiding false negatives is more important than avoiding false positives, in that if you have this AI and you believe it is not deceptive, but it actually is deceptive, that seems a lot worse. But in general, of course, there need to be some kind of balancing between these two kinds of errors. We may be able to use AIs with low precision if we have good adjudication. Like if there is a good, strong way of determining the truth of the matter, if one AI accuses another AI of being deceptive, then that would be helpful as well. If nothing else, even if we can't really understand and adjudicate, then we could just count the number of warnings. That may be helpful. I mean, yeah, it may be a little helpful, right? And if we are doing the thing where we try to lower the amount of free energy to harden the society in general, then AIs with low precision could perhaps also be valuable for this. So how effective will checks and balances be? Well, Holden-Karnofsky is optimistic about this and argues that even if the AIs tend to collude sometimes, then this will have benefits, because they will still give some level of protection, in that they will, like, if they explain some security vulnerabilities, then that will be helpful. And we could potentially make collusion quite hard. I don't know precisely how hard Holden-Karnofsky estimates that it's going to be, but variation is certainly something that will also make give more false alarms and make adjudication a lot harder, because we are probably going to be like, if there are different architectures or something like that, then we need to understand more architectures as judges. There's how the incentive scales is also an interesting case. We imagine that if the collusion becomes slightly less probable of succeeding, then that strongly reduces the incentives. I think that's interesting, and I think it's possible to do some work on trying to formalize this, which I think would be really helpful. Holden has this claim: reliably calculating the probability that AIs are caught in bad behavior goes a long way. I think it's a strange claim. I think definitely reliably calculating the probability that an AI will do a treacherous turn is something we're never going to have. Like, reliably calculating that, we are really grasping for straws, rather. I think the final key tool is to make supervision competitive, and this is supervision competitive with the supervised. So this previous generation of AIs that are supervising the next generation of AIs, and this kind of competitiveness should be distinguished from the competitiveness between MAGMA and the world. And basically, how do we ensure that supervision is competitive? Holden-Karnofsky suggests that we move cautiously and iteratively, and I think that is true, but I also feel like this is described like as a key tool, and there is basically this: be cautious and iterative, and that's kind of underwhelming to me. I think I would have liked to have some more ideas. I recognize it may be hard at this point to write a lot, but I think it's important, and it feels really thin to me. The final section of the post is called High-Level Factors in Success and Failure. When I read that title, I didn't quite understand what it was about. I think what it's basically about, what kind of future evidence we could see that would update us to be more positive or more negative. So one of them is whether it turns out to be natural or not that the AIs will play the training game. Playing the training game is not precisely the same as being deceptive. It's described as trying to appear as attractive to researchers as possible while disregarding their intent. And I tried to look into this. I think this kind of new definition is kind of strange. It doesn't really cut reality at the joints, because you can't appear attractive to someone without considering their intent. I would just say whether deceptiveness is naturally all that likely. We don't know. This is a difficult question. In theory, we could see AIs internalizing at an early stage that hacks that give legitimate rewards are not desirable. That would be really nice. Holden is not positive about this. He thinks it's unlikely. But if he learned this, then that would update him to be more positive about MAGMA's chances. A bad factor would be that if we learned that AI systems rapidly become extremely powerful relative to supervisors. So here there are two things. There are against the capabilities of the supervisors, which in the first generations are only humans and later will be humans helped by the previous generation narrow AIs, something like this. But the other thing that the AI systems could become powerful towards are human defenses. Like, how hard is it to convince people? How hard is it to actually take over the world? If it turns out that systems rapidly become extremely powerful, that is very bad news. And I think we should skip the words extremely and rapidly in this claim, because sure, if you put enough qualifiers, then obviously, but I think if it turns out that AI systems at some point, even at a slow speed, maybe eventually become powerful relative to supervisors, like even slightly more powerful, then that would also be very, very bad to learn that. So I think this should be split into two dimensions. Like, there is against the capabilities of supervisors to figure out whether the AI is deceptive. I think right now AI systems are quite capable of doing that, for the simple reasons that the supervisors are really, really poor. Like, we really don't have any good way to look at GPT-3 and say, is it deceptive or not? But against human defenses, it seems clear that AI systems are not anywhere near being powerful enough to just take over the world. So what would this look like in practice? It would look like AIs being able to deceive and manipulate humans, distinguish whether they are in training or deployment, find some kind of security exploits, and generate security suggestions with hidden backdoors. One thing I would note here is that it isn't actually required that the AI generates a security suggestion with a hidden backdoor that it can exploit itself. If it expects it will be replaced with a smarter AI, then it's good enough that it says that it notices that there is some subtle bug here that probably a smarter AI would be able to use as a backdoor. Another thing the AI may be able to do is to disguise their internal states, collude against together with each other, and just make adjudication too hard for humans. So you notice here that this part about why powerful AI is bad didn't really talk about alignment. But Holden-Konofsky says that this is really bad news if AI become powerful, because during training there's going to be a lot of different opportunities to defect and to take over the world or do different things. And like, if we strive for a big amount of variation, then almost certainly some of the AIs are going to be unaligned. And this seems to be a crux for many people, including the most optimistic and pessimistic. And I believe that, yeah, this could be close to one of the cruxes, and in particular a fact behind why some people are calling for a pivotal act, because we are probably going to need something that is really strong to prevent all other AIs from being able to do bad things if it turns out that AIs rapidly become extremely powerful compared to humans. Okay, the optimists at this point would probably say that, okay, if we make multiple generations, then why is it exactly that we need the next generation to be a lot more powerful than the previous? Couldn't we just do baby steps? Even if it turns out that increasing the intelligence of these systems is very easy, surely we could just lower the amount of compute and get something that is just slightly smarter, so we don't get something where the next generation is a lot smarter than the previous. Holden Karnofsky says, seems to be taken by this argument. I believe he thinks it's a really good argument, and says it's unclear about what the counter arguments to that would be. So the first counter argument I would give is that the standard story of AI takeover includes the AI hiding some of its capabilities, and that would prevent humans from very gradually turning up the heat instead of just giving it as much compute as possible. The second is that I feel capability is multidimensional. It's possible to have one level of capability that is against human defenses, like manipulating humans, breaking out of the box, hacking, taking over the world, and alignment, the ability to align other AIs. And there is no particular reason to expect these two to go precisely in the same level. I believe indeed that the alignment problem is very, very hard, and that would also make it very hard for the AI. There are a few more things we could learn. We could learn that adversarial training works really, really well. That would be a good thing. Holden Karnofsky is not optimistic about that. He believes that would require that effectively every input is identified that would cause unintended behavior. And that seems like a really, really big ask. But I don't think we actually need all that much. I think the key thing we need for adversarial training to be super effective is a really strong principled way to make the AI think that it is still in test when it is deployed. I think that's actually all we need. But of course, I also believe that this is really hard. Another thing would be if it turns out that decoding and manipulating internal state is really effective in some way. It may be that we can solve the alignment problem or global coordination using only rather limited AI systems. That would also be great. Another thing we could learn as we try to use AI systems to align other AI systems is that decisive alignment is just hard. And that would of course be really bad. Another key question that determines whether we will have success or failure is how cautious will MAGMA and others be. Because incautious behavior is just really attractive. There's an easy way around all these kind of problematic symptoms. Just train it away, basically. Putting all this delay and work on alignment is not perhaps easy to justify to shareholders, etc. And we're probably going to need a substantial amount of serial time, because human needs to be involved in many things such as resolving security flaws and adjudicating, and even if the AIs are more powerful, we need some serial time. Another thing that could happen is that we get a sub-existential catastrophe that could make MAGMA and others be more risk adverse. I think that is true, but I also think that one level below a catastrophe that is one level below helps, but two levels below do not help. So if we get a sub-existential catastrophe, that doesn't really help. Like if we get a lot of self-driving cars that crash into other self-driving cars, that would make a lot of people say, yeah, the problem is that the AI is not competent enough, so we need more competent AI. And so that doesn't really help us at all. So based on all this entire work, would civilization survive in this near-casting scenario where MAGMA realizes that they have 6 months to 2 years to try to prevent an AI catastrophe? Holden Karnofsky doesn't really give a strong suggestion to this. He can't resolve this. He believes that it is uncertain. It's not certain that it's impossible, and it's not certain that it's impossible. Somewhere in between seems reasonable. There are, in this situation, a small number of AI labs, and but one of them is probably incautious. I think it's too big of an assumption that they will all be cautious. Another advantage is that there are several possible paths to alignment, but unfortunately they all look kind of hard. So Holden Karnofsky ends up with saying like, maybe. To me, I think, in fact, that the actions that MAGMA take are not that relevant, because the suggestions given here are not pivotal acts in general, and they are unlikely to really flip the game board in any meaningful way. So I think the key question here for would civilization survive is, how hard is the alignment problem? How natural is it for AIs to be deceptive? This kind of thing. And how well MAGMA does, MAGMA can't really do that much with this small lead. So whether they're really competent or not, that doesn't change the probability of AI doom very much. That is all for today. Thank you and see you next week.